You know when you type something into a search bar on Wikipedia or Netflix or even your company's own internal site, and the results come back in like the blink of an eye? Ever wonder how that works? Well, a lot of the time, the secret sauce is an engine called Elasticsearch. So today, let's dive in and pull back the curtain on the magic that powers instant search.
Now, if you go looking for a simple explanation, you might stumble upon this absolute gem from a Reddit user. Stuff goes in, stuff comes out. And you know what? They're not wrong. That is, technically, what happens.
But the real mystery, the thing we're going to crack open today, is what on earth happens in between? How does all that stuff get organized so that the right bits come out almost instantly? That's the black box we're here to unpack.
So to get started, we actually have to look beyond the search bar itself. Because, yeah, Elasticsearch is famous for finding things, but its real genius, that comes from how it organizes things. To get why it's so fast, you first have to understand how it thinks about data. And its whole way of thinking revolves around one huge idea: ditching the old, rigid ways of storing data and embracing these flexible things called documents.
So forget about a traditional database that looks like a super strict spreadsheet with all its rows and columns. Instead, I want you to picture a digital filing cabinet. In that cabinet, every file is a document, a self-contained chunk of information written in a format called JSON. This is so important because it lets you store data the way it exists in the real world, like a whole user profile or a complete product listing, all in one place.
So when we say document, we're talking about the whole thing. A blog post with all its text, its tags, its comments, all bundled together under one unique ID. This document-first approach is really the foundation for everything else that makes Elasticsearch work.
Okay, now for the main event. This right here is the secret ingredient. This is the concept that makes Elasticsearch so mind-blowingly fast. It's called the inverted index.
To really get it, let's just use these two simple sentences as our documents. Now, imagine you needed to find every document that has the word quick in it. A traditional database would have to read document 1 word by word, then read document 2 word by word. It's super slow. Elasticsearch does something way smarter. It builds that inverted index. And honestly, the best analogy for this is the index you find at the back of a textbook. Instead of searching the whole book for a term, you just flip to the index, find the word, and it tells you exactly which pages it's on. That's what an inverted index does for data.
So with this index ready to go, a search for, say, quick brown isn't a slow scan anymore. It's just two incredibly fast lookups. The system looks up quick, boom, it's in docs 1 and 2. It looks up brown, boom, also in docs 1 and 2. It finds where they overlap, and there are your results, almost instantly. This is the secret to its speed.
Okay, so that explains the raw speed, but what about scale? How does this thing handle billions of documents and thousands of searches every single second? Well, the answer is all about how it scales out. It's a team game. See, Elasticsearch was built from the ground up to be a distributed system. If your data gets too big for one computer, Elasticsearch just automatically breaks it into smaller pieces called shards. You can think of each shard as its own little mini search engine. These shards then get spread out across multiple servers, or nodes, and they all work together as a team in what's called a cluster. It's brilliant because if you need more power, you just add another server to the team.
And searching across this whole team is really efficient. It's a two-step dance. First, in the query phase, one node acts as the coordinator and basically shouts out to all the shards, "Hey, for this search, what are the IDs of your top matching documents?" Then, once it gets those IDs back, it kicks off the fetch phase and says, "Okay, great. Now just send me the actual documents for these few IDs." It's super smart because it avoids shuffling tons of data across the network.
So how do you keep all these pieces happy? Well, there's no single magic number, but a really common guideline you'll hear from the community is to try and keep your individual shards under about 50 gigabytes. Keeping them in that sweet spot just helps the whole cluster balance the workload and keep everything running nice and fast.
Now, once you build an engine that is this good at finding and organizing information, something cool happens. You start to realize it's useful for a whole lot more than just powering a search bar. The same exact principles are perfect for all sorts of modern data problems.
I mean, of course, it's a world-class engine for full-text search. That's its bread and butter. But that same speed lets it do crazy-fast analytics in aggregations to power real-time dashboards and data visualizations. And because it can just gobble up massive amounts of log data, it's become a cornerstone of observability, which is just the fancy word for understanding the health of our complex modern software.
The key to all that analytic power is a feature called aggregations. This is what lets you ask bigger picture questions of your data. Things like, what are my top selling products? Or show me the most common errors happening right now. It's basically a tool for summarizing huge amounts of data on the fly.
For instance, imagine you have millions of user profiles. With a single aggregation query, you can get a result like this back in milliseconds, showing you instantly that music is the most popular interest among your users. This is exactly how those real-time analytics dashboards get built.
And this ties right back into observability. In today's world, applications are incredibly complex and spread out. Being able to search and analyze just massive streams of logs and metrics is no longer a luxury, it's essential. As this research paper puts it, this capability is absolutely necessary to keep our digital world running smoothly.
So when you put it all together, this description from the official guide really just hits the nail on the head. It's not just a search engine anymore. Elasticsearch is a distributed, real-time search and analytics engine.
So there you have it. We went from stuff goes in, stuff comes out, all the way to understanding the engine inside. We've seen how that inverted index gives us instant results, how shards let it scale to massive sizes, and how aggregations can find trends in a sea of data. It really is the hidden powerhouse behind so much of our digital lives. So, now that you know its secrets, where do you think you'll see it working next?